Good day, my name is Mr. Gideon. Today we'll be looking at logarithm and indices. I would like you to get your writing materials ready with your calculators. We'll be back shortly. Welcome back. Today we'll start with what is indices. Now, by definition, indices can be defined as repetition of numbers multiplying themselves. Okay, let's look at it as 2 times 2 times 2 times 2. Now, if we want to write this in indices form, this will become 2 raised to the power 1, 2, 3, 4. How many times is multiplying itself? 4. We can also look at 3 times 3 times 3. So if we are writing this in indices form, it will become 3 raised to the power 1, 2, 3, raised to the power 3. Okay, now indices have certain laws that guide its operation. Now we'll look at laws of indices. Now in laws of indices, I would like to start with what I call multiplication law. Now, under multiplication law, this law simply states that when you have x raised to the power a times x raised to the power b. Now, notice that both are of common terms. Okay, you have x raised to the power a and x raised to the power b. This can be written as, since they are of common terms, this will become x raised to the power a plus b. Example, if we have 2 raised to the power 5 times 2 raised to the power 3, this can be rewritten as 2 raised to the power 5 plus 3, which will give us 2 raised to the power 8. Now, to simplify this, let's look at it this way. 2 raised to the power 5 is 2 multiplying itself 5 times. This will become 2 times 2 times 2 times 2 times 2 times 2 raised to the power 2 multiplying itself 3 times. 2 times 2 times 2. Put all together, we have 1, 2, 3, 4, 5, 6, 7, 8. That will give us 2 raised to the power 8. So that's why we are having, when we're having a number of same base raised to any 2 different numbers, we can simply add them. Another example, let's look at 10 raised to the power 5, 10 raised to the power 3 times 10 raised to the power 2. Now with this, applying our law of x equals to a plus raised to the power a plus b, this becomes 10 raised to the power 3 plus 2, which will give us 10 raised to the power 5. Explaining it, expatiating it in this way, this becomes 10 times 10 times 10, 3 places, times 10 times 10, which when we add all together, we have 1, 2, 3, 4, 5. 10 raised to the power 5. Alright, the second law we are going to look at is our division law. Now, our division law simply states that when we have x raised to the power a divided by x raised to the power b, this will simply be x raised to the power a minus b. Example, if we have 5 raised to the power 3 divided by 5 raised to the power 2, this is going to be 5 raised to the power 3 minus 2, which is 5 raised to the power 1. Let's simplify this. We have 5 raised to the power 3, which is 5 times 5 times 5, all over 5 raised to the power 2, 5 times 5. 5 cancels 5, 5 cancels 5, leaving us with 5 raised to the power 1. Let's look at another example. Example 2. If we have 8 raised to power 6 divided by 8 raised to power 4. Now this will give us 8 raised to power 6 minus 4, which is 8. 6 minus 4 raised to power 2. Simplifying this, we have 8 times 8 times 8 times 8 times 8 times 8 divided by 8 times 8 times 8 times 8. This cancels this, this cancels this, this cancels this, this cancels this, leaving us with 8 raised to power 2. Alright, looking at our third law, which is the power law, it says x raised to power a bracket b. Now, this simply means that the figures you have at your raised to power would become x raised to power a b, or a dot b, a times b, whichever you would understand. Now, example of this is if we have 10 raised to power 3 or raised to power 2. Now, this simply means that this is 10 raised to power 3 times 2, which is 10 raised to power 6. Another example we could use here is if we have 2 raised to power 4 times raised to power 3. This becomes 2 raised to power 4 times 3, which is 2 raised to power 12. Alright, looking at our next law, which is the zero law. The zero law simply states that any number or alphabet raised to power 0 is equal to 1. So if we're having 100 raised to the power of 0, it's equal to 1. If we're having 10 raised to power 0, it's equal to 1. b raised to power 0 is equal to 1. The only exception we have here is if our x or alphabet or number is 0. As long as it is not equal to 0, it is equal to 1. So always bear in mind that your zero index law states that as long as your number is not equal to 0, any other number that is raised to the power of 0, it's equal to 1. Now looking at the negative index law. Now our negative index law simply states that when you have x raised to minus 2, okay, x raised to minus 2 can be written as a fraction as 1 all over the positive of x raised to 2. Now look at this negative sign introduces our division sign. So whenever you have 5 raised to power minus 2, this can be rewritten as 1 all over 5 raised to power 2. If we have 10 raised to power minus 3, this can be rewritten as 1 over 10 raised to power 3. So our negative index law simply removes our negative sign and makes it positive by introducing 1 all over the positive of our number. Now to our fractional index law. Our fractional index law talks about x raised to power m all over n. Now, if we have our x, the power is in fraction. That's what makes it different from our index law. The power of this is in fraction. So if we look at this, if we want to simplify this, this becomes the nth root of x raised to power n. In some textbooks, you will see it as nth root of x all raised to power n. They all mean one and same thing. So when you example, if we look at 2 raised to power 3 over 2. Now, okay, let me not use 3 over 2 because our root sign is already 1 over 2. Let's say 3 over 4. Now, this simply means the fourth root of 2 raised to power 3. Now, if we have 5 raised to power 3, 4 over 6, this means the sixth root of 5 raised to power 4. So this for our fractional index law. All right, let's look at a few examples on how to apply our laws. Question 1 says simplify 125 raised to power negative 1 over 3 times 49 raised to power negative 1 over 2 times 10 raised to power 0. Now, which of the laws are we going to apply for this? If you can see, we would apply our negative index law. Why? Because we have a negative. So for solution 1, we have 125 raised to power minus 1 over 3 times 49 raised to power minus 1 over 2 times 10 raised to power 0. Now for this, we can rewrite this to be 1 all over cube root. Okay, before I go into this will become 125 raised to power 1 over 3, the positive part of it, times 1 all over 49 raised to power half times 10 raised to power 0. Now, if we apply our fractional index law to our denominator here, this becomes 1 all over cube root of 125 times 1 all over half. In mathematically, our square root is raised to power half. So half of 49 raised to power half is square root of 49 times, from our zero index law, we learned that anything raised to power 0 is 1. So 10 raised to power 0 will give us 1. Now, the cube root of 125 will be what? The cube root of 125 simply means what number would you multiply 3 times to give you 125? And that will give you 5. So the cube root of 125 will be what? 5. That will be 1 over 5 times square root of 49 is 7 times 1 all over 1. So this will give us 1 times 1 times 1 will give us 1. 5 times 7 will give us 35. 35 times 1 will give us 35. So our answer will be 1 over 35. Now, to the second question. It says 25 raised to the power of minus half times 27 raised to power 1 over 3 plus 121 raised to power minus half times 625 raised to power minus 1 over 4. Now, applying same rules we apply to this, we are going to have 1 all over 25 raised to power half times cube root of 27 plus, now notice we are not putting 1 all over in this because this is positive. We only introduce our 1 over 25 here because this is negative. So this becomes 1 over 121 raised to power half times 1 over 625 raised to power 1 over 4. Now, applying our laws where that says that our raised to power half is square root, this becomes 1 over square root of 25 times cube root of 27 plus 1 over square root of 121 times 1 over the 4th root of 625. Now, square root of 25 is 5 times cube root of 27 is what number would multiply itself 3 times to give you 27, and that is 3 times 3, 9, 9 times 3, 27. So the cube root of 27 will be 3 plus 1 all over square root of 121 is 11 times 1 all over 4th root of 625 is 5. Now, having this, we can now collect our terms together. So if we collect our terms together, we are going to have 3 times 1, 3 over 5, plus 1 times 1, 1, all over 55. 11 times 5, 55. Now, what is the LCM of 55 and 5? LCM of 55 and 5 will give us 55. So 5 into 55, 11. 11 times 3 will give us 33. So this will become 3 times 11 plus 55 here, 1 times 1. So this will give us 3 times 11 will give us 33 plus 1 all over 55, which is 34 over 55. Logarithm is the inverse of indices. Now, in indices, we looked at the powers. Okay, now in logarithm, we are using logarithm to find the exponent. So that's why it says logarithm is the inverse of an exponent, or the inverse of your indices. Now it says if a raised to power x equals to b, then log a b equals to x. Now, where x is the power to which it is raised, a is the number to which x is raised, and b is your answer. So let's look at an example. If 3 raised to power 5, okay, 3 raised to power 3 equals to 27. 3 times 3 times 3, which is 27, then log 3 raised to power 27 equals to 3. That's what this is simply saying. Where this is your x, this is your a, and this is your b. Okay, let's look at another example. If 2 raised to power 5 equals to 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, and 16 times 2, 32. So 2 raised to power 5 equals to 32. Then log x, our log 2, 5 will be what? Our log 232 will be equals to 5. All right. Now, looking at the laws of logarithm, we have our first law as the product law. Now, our product law simply states that if we have log base b x y, it can be separated to be log base b x plus log base b y. Now, look at, it's like the inverse of your indices. In indices, when we have our b raised power xy, x times y, we are having it as b raised power x plus y. Now, in this, since we are dealing with log, this becomes log base b xy will give us log base b x plus log base b y. Example, if we have log 2 5 times 3, now this will be log base 2 5 plus log base 2 3. That's for our product law. Then our quotient law or division law, which we are going to look at as which is log base b x over y equals to log base b x divided by log base b y. Okay, this can be rewritten as log base b x minus log base b y. Now, for our example, let's look at an example where we have, if we have log 10 5 divided by 2, this can be written as log 10 of 5 minus log 10 of 2. Looking at our power law, we have log a m raised power n. Now, it can be rewritten as the power to which m is raised to is brought down to have n log a m. Now, let's look at an example. If we have log 5 2 raised power 3, this can be rewritten as our raised power 3 here will be brought down to 3 log 5 2. Okay, now our next law there is change of base of formula. If we have log a m, this can be written as log b m all over log b a. Now, you can see that the change of the base, which is our log, was changed from a to m, and m is now divided by the former base n. Now, we will go into examples on how to apply those laws. Log 3, our example 1 will be log 3 plus log 7. So for us to work on log 3 plus log 7, now remember our first law, which is our product law. This is going to become log 3 times 7, which will give us log 21. Okay, now our second example is log 6 minus log 2. Applying our quotient rule or division law, it will have, we are having log 6 divided by 2, which will give us log 3. Okay, now to the third one, we have log base 2, 2. Now, in logarithm, whenever you have a log of same number, that is equal to 1. So if we're having log 10, 10, that is 1. Log 100, 100, that is 1. So it's important to always remember this. Now, the next example we have there is our log base 2128. Now, for us to solve this, we have to break down our big figure 128. Now, if we are to break down this number, we are going to look for what number would multiply itself to give us 128. And if we do that, let's start with our lowest term of 2. Now, we can see that if we have 128 divided by 2, that will give us 64. Divided by 2, that will give us 32. Divided by 2, that will give us 16. Divided by 2, that will give us 8, 4, 2, and 1. So we can see 1, 2, 3, 4, 5, 6, 7. So 128, we can rewrite this to be log base 2, 2 raised power 7. Now, if we have it as this, we can now bring down our 7, applying our power rule to this. Bringing down our 7 down to have it as 7 log 2, 2. Now, applying this law that says when we have our base equal to the number of our log, it's equal to 1. That will now become 7. Okay, let's say since log 2, 2 equals to 1, this will now become 7 times 1, which will give us 7. Now to the fifth question, where we have log 81, log base 81, 3. Okay, now if we apply our change of base law, this will become log 3 over log 81. Now, having this as log 3 over 81, we can now break down 81 to an indices form, looking for the number that can divide 81 and how many times it will be. Now, if we do that, we'll see that 81 will become log 3 all over log 3 raised power 4. That is 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. So if we have this as this, we can rewrite this to become log 3 all over 4 log 3. Now log 3 can cancel out, leaving you with 1 all over 4. Now to our last question, which is log 5, 1. Now it is important to note that any number, any log of any base raised by 1 is equal to 0. That means if we have log 100, 1 equals to 0. Log 10, 1 equals to 0. For watching today. If you have any questions or comments, drop it in the comment section below and we'll reply you. Please also do like and subscribe to our channel and click on the subscription button to always get notified for any updates. Thank you.
Hi, if you have not subscribed to this channel, you can do so in 5 seconds. 5, 4, 3, 2, 1. And don't forget to hit